Hi guys, welcome back to another vid, and for this vid I will be doing the summary of chapter 5. So stay watch, stay tuned guys, and I hope you got some information and you learned something about the chapter 5, and I will be back guys. Okay guys, so for our chapter 5, the Ethernet. So the OSI model physical layer provides the means to transport the bits that make up a data link layer frame across the network media. So Ethernet is now the predominant LAN technology in the world. So Ethernet operates in the data link layer and the physical layer. So the Ethernet protocol standards define many aspects of network communication, including frame format, frame size, timing, and encoding. So when messages are sent between hosts on an internet network, the hosts format the messages into the frame layout that is specified by the standards. So because Ethernet is comprised of standards at these lower layers, it may best be understood in reference to the OSI model. So the OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. So Ethernet standards define both the layer 2 protocols and the layer 1 technologies. So although Ethernet specifications support different media bandwidths and other layer 1 and 2 variations, the basic frame format and address scheme is the same for all varieties of Ethernet. So for this chapter, it is examining the characteristics and operation of Ethernet as it has evolved from shared media, contention-based data communications technology to today's high bandwidth full duplex technology. So our MAC sublayer. So the Ethernet MAC sublayer has two primary responsibilities. The first one is the data encapsulation. So the data encapsulation is the data process includes frame assembly before transmission and frame disassembly upon reception of a frame. So in forming the frame, the MAC layer adds a header and trailer to the network layer or the PDU. So data encapsulation provides three primary functions. So what are those three? So the first one is the frame delimiting. So the frame delimiting is the framing process provides important delimiters that are used to identify a group of bits that make up a frame. So these delimiting bits provide synchronization between the transmitting and receiving nodes. So the second one is the addressing. The addressing is the encapsulation process contains layer 3 PDU and also provides for data link layer addressing. And the last one, the third one is the error detection. So each frame contains a trailer used to detect any errors in transmission. So the use of frames aids in the transmission of bits as they are placed on the media and in the grouping bits at the receiving mode. So the next one for our MAC sublayer primary is the media access control. So the second responsibility of the MAC sublayer is media access control. So media access control is responsible for the placement of frames on the media and the removal of frames from the media. So as its name implies, it controls access to the media. So this sublayer communicates directly with the physical layer. The underlying logical topology of Ethernet is a multi-access bus. Therefore, all nodes, devices on a single network segment share the medium. So Ethernet is a contention-based method of networking. So a contention-based method means that that any device can try it to transmit data across the shared medium whenever it has data to send. So the carrier sends mass multiple access or collision detection, or the CSMA or CD. And process is used in half duplex Ethernet LANs to detect and resolve collisions. So today's Ethernet LANs use full duplex switches, so which allow multiple devices to send and receive simultaneously with no collisions. So the MAC address and the hexadecimal. So an Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits. So 4 bits per hexadecimal digits. So just as decimal is a base 10 number system, so hexadecimal is a base 16 system. So the base 16 number system uses the numbers 0 to 9 and the letters A to F. So the equivalent decimal and hexadecimals vary binary 40, so 0000 to 41, so 1111. So it is easier to express a value as a single hexadecimal digit than as 4 binary bits. So the hexadecimal conversions, number conversions between decimal and hexadecimal values are straightforward, but quickly dividing or multiplying by 16 is not always convenient. So if such conversions are required, it is usually easier to convert the decimal or hexadecimal value to binary. So and then to convert the binary value to either decimal or hexadecimal as appropriate. So switch fundamentals. So a layer 2 Ethernet switch uses MAC addresses to make forwarding decisions. So it is completely unaware of the protocol being carried in the data, and the portion of the frame such as an IPv4 packet. So the switch makes its forwarding decisions based only on the layer 2 Ethernet MAC address. So unlike legacy Ethernet hubs that repeats bits of out all ports except the incoming port, an Ethernet switch consults a MAC address table to make a forwarding decisions for each frame. So the 4-port switch has just powered on. It has not yet learned the MAC address for the 4 attached PCs. So the duplex and speed settings. So two of the most basic settings on the switch are the bandwidth. So and duplex settings for each individual switch port. So it is critical that the duplex and bandwidth settings match between the switch port and the connection devices, so such as a computer or another switch. So there are two types of duplex settings used for communications on an Ethernet network. So the first one is the full duplex. The full duplex is the both ends of the connection can send and receive simultaneously. And the next one is the half duplex. Only one end of the connection can send at a time. So auto negotiation is an optional function found on most Ethernet switches and ICs. So auto negotiation enables two devices to automatically exchange information about speed and duplex capabilities. So the switch and the connected device will choose the performing mode. So full duplex is chosen if both have the capability along with their highest common bandwidth. So the destination on same network. So there are two primary addresses assigned to a device on an Ethernet LAN. So the first one is the physical address or the MAC address. So used for Ethernet NIC to Ethernet NIC communications on the same network. So the next one is the logical address or the IP address. Then used to send the packet from the original source to the final destination. Then IP addresses are used to identify that the address of the original source and the final destination. And the destination IP address may be on the same IP network as the source or may be on a remote network. So layer 2 or physical addresses like Ethernet MAC addresses have a different purpose. So these addresses are used to deliver the data link frame with the encapsulated IP packet from one NIC to another NIC on the same network. So if the destination IP address is on the same network, the destination MAC address will be that of the destination device. So the Ethernet is the most widely used LAN technology today. So it is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. So most Ethernet networks and devices are really typically connected on a point-to-point basic to a layer 2. So full duplex switch, a layer 2 LAN switch performs switching and filtering based only the OSI data link layer or the layer 2 or the MAC address, and a layer 2 switch builds a MAC address table that uses to make forwarding decisions. And layer 2 switches depend on a router to pass data between independent IP subnet networks. So guys, that's all for the summary of chapter 5, and I hope you got something from me, and I hope you get some information about me, and stay watch for my next video about the summary of chapter 6. That's all guys, thank you for watching.